Okay, right angle trigonometry. You've done lots of work with right triangles before. You've done the Pythagorean theorem. We've done finding the area of right triangles. And you've probably in geometry probably even looked at the basic trigonometric functions. And what a trigonometric function is, it tells us the ratio of two sides of a right triangle. And with the ratio of them, we have three different main trigonometric functions that we talk about: sine, cosine, and tangent. And then in the last example today, we'll actually look at the ones that are called the reciprocal functions of them, which are cosecant, secant, and cotangent. But when you're talking about sine, cosine, tangent, they're all defined differently, but they're all defined with a right triangle in mind. Sine is defined as the leg opposite a specific angle over the hypotenuse. So it's a ratio of the opposite side over the hypotenuse. Cosine is defined and abbreviated as COS, defined as the adjacent side over the hypotenuse. And tangent is defined as the opposite leg over the adjacent leg. Now, it's important that one of the things that we're going to be doing as we go through this today is identifying adjacent, identifying opposite, like that. And one of the things that that is the easiest way to do as far as the adjacent side is concerned is understand the adjacent side of an angle is the side that helps make the angle. Okay, so with the right triangle, there's three angles in there, right? Okay, the one we're not concerned about when we talk about sine, cosine, and tangent is the right angle. Right, that's always there. It's always the same. Doesn't change. Okay? The other two angles are the ones that we're concerned about. But when you notice, the hypotenuse is always one of the sides that makes the other two angles. All right, so in this triangle here, we have the blue side is the hypotenuse, always the side across from the right angle and always the longest side. Okay? The other two sides depends on which angle you're talking about. Okay? But the adjacent side is always the side that helps make the angle with the hypotenuse. Okay? So right now, with where this angle theta is, and that little symbol is called theta, and it's a circle with a line through the middle, a horizontal line through the middle. And the green side here is the adjacent side because it helps form the angle for theta. And which means then the red side then is going to be the opposite side. So for this specific triangle, sine is equal to opposite over hypotenuse, so that would be 4 over 5. Cosine is equal to adjacent over hypotenuse, so 3 over 5. And tangent is equal to opposite over adjacent, which is 4 over 3. So you are going to have to memorize them. Okay? And so one of the easiest ways to do that is there is they call it mnemonic, right? Or something like that. I can't say it specifically. It's English word that it's SOHCAH and TOA, right? SOHCAHTOA, all right? And that means that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? So you could actually write sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and tangent, opposite, and adjacent. Right? SOHCAHTOA. And the reason is that you need to memorize that is because when you do get to some of the testing that you have to do, like with the SAT and other things, that you will have to remember those things because they're not going to tell you what they are. Right? They'll give you some information on them, but that's not one of them. All right. So this right triangle here has the sides 7, 25, and 24, and they want us to find sine, cosine, and tangent. So the first thing that I do when I have a new triangle I'm working with and I'm concerned about with the trig functions, I'm going to label the sides whether they're opposite, adjacent, or hypotenuse. That's the first thing I'm going to do. That way it'll help me to determine where things are and help me with sine, cosine, and tangent. All right. So first of all, the easiest one to tell is the hypotenuse, right? All right. So Jordan, which one's the hypotenuse? All right, 25. So here's the hypotenuse here. Side across from the right angle, always the longest side. Okay. All right. So, RJ, what's the adjacent side then? 24. Okay. Since 24, this side is 24, helps make this angle, then the 24, that side is the adjacent, which leads the 7 as the side that's opposite. And it's always across from the angle is the opposite side. So when we write them, we write SIN of whatever this angle name is. In this case, they're using theta, so I'll put SIN for sine. Sine of theta equals 7, the opposite, over 25, the hypotenuse. Cosine, COS of theta, so cosine of theta, is the adjacent side over the hypotenuse, so 24 over 25. And tangent, which is TAN, theta is the opposite over the adjacent, 7 over 24. So, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And the reason it's very important that you memorize them very quickly is because we're going to be doing application problems, and with the application problems you're going to need to be able to recall which one to use right away rather quickly, so you either need to have it memorized or have it at your disposal very easily too, or quickly. Okay. Now also, with working with the right triangles, there are two specific right triangles that are used quite often in mathematics. There is the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. And you're going to need to memorize them. Okay? So there's two things that you're going to have to memorize, and we're actually going to have a quiz over them, how well you memorize them, on Wednesday. Okay, I'll make it Wednesday instead of tomorrow. Thought about tomorrow, but we'll do it Wednesday. Okay, so you're going to have the 6 trig functions, okay, sine, cosine, tangent, and then the other 3, which are cosecant, secant, and cotangent. We'll talk about them at the end of the lesson, the last example. And you have to have these 2 triangles memorized. Okay, so the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. Now, when you did geometry, that you probably saw both of these in geometry, except for they put X's next to the numbers instead of just the numbers there. Okay, so because I could put any number in there, and that should be a true statement then. So with the 30, 60, 90 right triangle, our 3 sides are 1, 2, and the square root of 3. And the 45, 45, 90 are 1, 1, and the square root of 2. Okay. So then when we do sine, cosine, and tangent of each of those angles, then they give us these ratios that make up the rest of this table. And if you have the 2 triangles written down, then the other information is, you can figure that out. So, too. When those of you who are going to take pre-calculus, that you'll have to have that whole thing memorized, plus when we put it into a unit circle. We're going to, in a couple lessons, we'll look at this thing called the unit circle, and all of those numbers help make up the unit circle. So when you're solving triangles and they give you 30 degrees or 60 degrees or 45 degrees, then I'm going to expect you to give me exact answers. Okay? If they use angles different than those, then we'll use approximate answers and we'll use our calculator to find those specifically. So example 2, we're going to find the value of side x. Now when I write this on my paper, I would write it so that either one of these two sides sits on the horizontal. Okay? So instead of it being on an angle, I would make it so that it's flat. Okay. So in other words, what I would do is I would turn it so that it looks like that. All right, to help me, so it looks like a right triangle more specifically, or turn it. Oops, not quite that far. Here, so it looks like a right triangle. Okay, so when I draw it on my paper, I'm going to draw it that way. So, to find side x, we need to know the sides of the triangle and what they mean. Right? So we're working with this angle here that's 30 degrees. So they give us the angle. We need to know what do those other two sides represent. Okay? They give us 74. Right. So Jasmine, 74, is that the opposite, the adjacent, or the hypotenuse? Okay. Is it the hypotenuse of the triangle? Is it across from the right angle? Yes. Okay. So the 74 is the hypotenuse. Okay. This side here that's not labeled then would be what? The adjacent side, which means then that side x I'm trying to find is the opposite. Okay? Since it's across from the angle I know, or the angle I'm trying to find, then that would be the opposite side. So when I look at my list of sine, cosine, and tangent, so we'll write those up here again. So, katoa. All right. So which one of those three involves the opposite and the hypotenuse? Okay, let's see. O and H. Okay, we have OH here, AH, OA. So that would be sine. So sine of theta equals the opposite over the hypotenuse. Well, theta is the angle I know, which in this case is 30. So we say the sine of 30 equals the opposite, which is x, over the hypotenuse, which is 74. So like I said, whenever you have a 30, 45, or 60 degree angle, we always want to use the exact value. So I can look at this chart that looks like most of you put on your paper, and it tells me the sine of 30. So what is the sine of 30 degrees? Okay. Sine of 30 degrees, first one here, is equal to 1/2. So I'm going to put in 1/2 for sine of 30. And then I can solve this proportion. Right. So then all we need to do is multiply by 74, both sides. So x equals 37. And make sure you pay attention for any time you have units that you put the correct units on there. Yes, Jaylene?
Would it be possible to just cross multiply?
Yes, you could. Yep. In some instances, depending on the ratio that we have. But since all I need to do is get rid of the 74. I'll just multiply by that. But yes, you can cross multiply if you prefer to do it that way. Okay. So, all right, let's look at a situation where they don't give us a nice angle of 30, 45, or 60. So to do this, though, we have to check our calculator first of all. So go to your calculator, and we want to make sure that we are in degrees. So go to the mode on your calculator, and where it shows down here, the third or fourth one, it should say radian in degrees. Make sure it has degrees highlighted. All right, especially if you're using one from the back counter, because my pre-calc students use those also, and they go back and forth from radians and degrees. So you'll only be using degrees for the most part. All right? We will look at radians in a couple days, but mostly you're looking at degrees. Anytime you're dealing with an application problem, you'll always be working in degrees. Okay, so make sure of that. For right now, though, you always want to be in degrees. So in a water skiing competition, jump ramp has a measurement shown to the nearest foot. All right, and make sure you pay attention to those kinds of things too. Here, where do I need to round to? All right, so here it says round it to the nearest foot. What is the height above water that a skier leaves the ramp? So always draw the triangle on your paper. Label the triangle, sides, whether they want the information they give you. Is it opposite? Is it hypotenuse? Is it adjacent? So that you can figure out whether I'm using sine, cosine, or tangent. All right. So Jake, what's the 19 in this case? Which side? Okay, the hypotenuse. All right. So Daniel, what's the H then? Opposite. Yep, good. It's this across from the angle that we know. So it's the opposite side. So they're nice to us. They give us opposite over hypotenuse, which again is sine. And you won't use sine all the time. Actually, we use tangent more than we use sine and cosine probably. So the sine of 15.1 equals h over 19. Since we don't know what the sine of 15.1 is, then we're going to go ahead and multiply by 19. And then all we have to do is just type that into our calculator. And we're going to use approximate this time because it's not going to be an exact value. So when you go to your calculator, just type in 19 times the sine of 15.1. Make sure you always put the angle after the trig function. So we get approximately 4.95. So the height of the water skier is about 5 feet, right? I mean feet or meters? Feet, okay. And he leaves the ramp, I suppose. And for the rest of the marking period or the rest of the semester, I'm going to require this. Okay? Tell me what your answer means. Okay? Don't just give me h is 5 feet. Tell me what it means. Okay? All right? When an object is above or below another object, you can find distances indirectly by using the angle of elevation or the angle of depression between the objects. So if we look at this picture, that we have an airplane and we have, looks like probably the tower at the airport, right? What do they call that tower?
It's the one that like the person's up in the tower and you like scan to make sure that it's all good or like contacting back.
Right.
Observation board.
An observation board? Yeah. What's that tower called? Anybody know? I can't think of it off the top of my head now. But they call it something specifically at the. What are these guys? What are the? See, I lost it completely. Air traffic control tower. That's it. The traffic control tower. I just couldn't think of the name of it right there. Okay. So if you're standing in the tower and you're looking at the plane, okay, that would be an angle of elevation, because when you look out to the horizontal and up, okay, that's an angle of elevation. Okay, so I'm looking out and up is elevation, and from the plane to the tower is the angle of depression, where he looks out and then down to see the tower. That would be the angle of depression. So out and up is elevation, out and down is depression. Yes. Okay. Now, notice what's true about those two angles in this situation. Anybody know? Let's go back to your geometry days. Okay. There's something true about those two angles in this picture. They are congruent. Do you know why?
Because they're on like that same like line, and they have like I don't know that.
So, because these two look out towards the horizon, right? The two dotted lines. Okay, so they're parallel, right? And this would be the transversal line. Okay, and so those are alternate interior angles. Okay, so the angle of depression and angle of elevation are actually the same angle because they're alternate interior angles. All right, so here we go. We got a biologist whose eye level is 6 feet above the ground, measures the angle of elevation to the top of a tree to be 38.7 degrees. If the biologist is standing 180 feet from the tree's base, what is the height of the tree to the nearest foot? Okay. So it's important that you draw your pictures correctly. So first thing, we have a biologist, right? So we need to draw him. Okay, so here's my biologist. Right? So he's looking out at a tree. Here's my tree. Right? Probably should be a lot taller than that, but that's okay. We don't worry about scale too much. We worry about our numbers. Okay. All right. Now, what are the important things that are in this about the biologist and the tree? What do we know? Okay. All right. First of all, what, Brittany?
They're 180 feet apart.
Okay. So this distance here is 180 feet. Okay. We know that. All right. What else, Mackenzie?
His eye level is 6 feet above the ground.
Okay. His eye level is 6 feet above the ground. Okay. Why is that important?
Because it gives us another side length.
It does give us another side length. Okay. It adds a challenge to this problem. Okay. So, all right. We have one other number there, 38.7 degrees. It says is the angle of elevation to the top of the tree. So remember, angle of elevation is we look out and up. So this angle here is 38.7 degrees. So here's the right triangle I have. It's this purple triangle here. And they want to know what is the height of the tree to the nearest foot. So the distance from his eye to the tree is 180 feet. And we need to find this value over here of this purple side of this right triangle, and I'm going to call that x. Now, is that the height of the tree? No, it's not, right? Because we also have what included in there?
The 6 feet.
Right, the 6 feet. Because we have to take that into account, because the right triangle I have does not involve that 6 feet. So when we're all done, we're going to have to add that. Yep. Okay. So 180 is which side of the right triangle then? Okay, the adjacent side helps make the angle. Yep. And x, that side, what is that part of the right triangle? Opposite, okay. So which trig function does opposite and adjacent? All right, so tangent of theta equals opposite over adjacent. So the tangent of 38.7 equals x over 180. So we multiply by 180. And x is approximately, so we go to my calculator, 180, always put that number in first, times the tangent of 38.7. I don't have to type that number in first, but if I don't use the parenthesis, if I do tangent of 38.7 times 180 and forget the parenthesis, it'll be wrong because it'll include that 180 in the measure of the angle. Okay? All right, so 144.2. All right, so let's go back to the question. All right, the question is, what is the height of the tree to the nearest foot? And we still have to take what into account?
The 6 feet.
Okay, the 6 feet. Okay. So the height is equal to 144 plus 6, or 150 feet. Okay, height of the tree is about 150 feet. All right, last one. Okay. All right, there are 3 other trig functions. Cosecant, which is abbreviated CSC, secant, which is abbreviated SEC, and cotangent, which is COT. And those are the reciprocals of the other 3 trig functions, sine, cosine, and tangent. So cosecant is the reciprocal of sine, so cosecant is hypotenuse over opposite. Secant is the reciprocal of cosine, so it would be hypotenuse over adjacent. And cotangent is a reciprocal of tangent, which would be adjacent over opposite then. So they're not really new. We're using the same information. We just have to flip our numbers over. So all we're going to do with these is that we could use some of them to solve triangles, but since sine, cosine, and tangent are on our calculator, we'll always, whenever we're trying to solve a triangle, as far as like the application problems will always use sine, cosine, and tangent. Okay. All right, so here we have this right triangle. And they want us to find the values of the 6 trigonometric functions for angle theta. So they give us 24 and 70. What do those two sides refer to? Okay, which one's which?
24 is adjacent.
Okay. All right, 24 helps make the angle, so that's adjacent, and 70 is across from the angle, so that's the opposite. So I'm missing something, right? Okay, the hypotenuse. So how do I find the hypotenuse? Okay, the Pythagorean theorem. So a squared plus b squared equals c squared. And the hypotenuse is always c. So we can go ahead and put in 24 and 70 for A and B. So take our calculator, do the square root of 24 squared plus 70 squared. Make sure you square them separately, not together. Okay. All right, so we get 74. And that's our hypotenuse. All right. So, my suggestion to you, when you are finding the 6 trig functions then for this triangle, is I would write sine, cosine, and tangent on the left, and then across from them, I'll put the reciprocal function of that. So then I'll leave space here, put cosecant, then secant, and then tangent, or cotangent, excuse me. They just seem that way because you've never seen them before. All right? So this way I know once I have sine, cosine, and tangent simplified, all I need to do is flip them over to get the other 3, and they're right next to them. Okay? So sine, opposite over hypotenuse, 70 over 74. And you must always simplify the fractions, okay? And then to do cosecant, then I just flip that one over. All right? Just take my final one and flip it over. So you go ahead and do the other. And here's your assignment.